All right, 6.2 today. So we're going to continue on talking about probability. And today we're going to talk about the difference between discrete probability. Remember, discrete we talked about yesterday. And discrete means like it's like definable, countable, like 1, 2, 3, and so on like that. And then we're going to kind of compare that to continuous. And continuous means, of course, there's infinitely many gaps, 1.11, 1.1111, 1.1113, and all that kind of business, okay? So we're going to talk about this today. It's called How Much Do You Get Paid? And so suppose you got a new job, and each day your boss draws a slip of paper from a bag that determines your wage for that day. Now that would be really interesting if your wage changed every single day, right? So here are the possibilities. You can make $1, you can make $5, $7, $10, $15, or $25 an hour. And it all depends on you reaching in and pulling out a slip of piece of paper. So not always a great thing. So let's just say that we kind of did this and we had 30 people that came in for the day and they reached in and they pulled a slip of paper out, okay? So let's say that 3 out of the 30 people picked a $1 wage. 6 out of 30 picked a $5 wage. 7 out of 30 picked a $7 wage. 10 out of 30 picked a $10 wage. 3 out of 30 did a $15 wage. And there was only one person that picked the $25 one. Okay, so is X, which is your wage, a discrete random variable? Is it definable? Well, yes, it has a countable number of values with gaps. So in other words, so $1 and then there's a gap between $1 and $5. You can't make $1.50. You can't make $1.51 and so on and so on. So there are gaps that are very definable in between of these. So what would be the probability that a student makes $17 per hour or more? Well, that's just saying that we want our value to be 17 or more. Now, notice there's a greater than or equal sign because it could be 17, but 17 is not on our chart. So it would have to be bigger than 17. Well, there's only one person who's making more than $17. So that's 1 out of 30, right? So 1 out of 30 people making more than $17. Okay. So option 2 now says your boss decides she could assign wages so that employees can get any amount, even crazy decimals, like, I don't know, $6.70 or $6.67 an hour, right? From $10 to $20. I was just kidding, I guess. From 10 to 20. And all of those amounts are equally likely. Okay. So you can make $10, $10.01, $10.20, $19.99. All of those are possible. Okay. Is this a discrete random variable? Well, this is no, since there are infinite possible values with no gaps. So in other words, you can make, $10.01, $10.02, $10.03, and all the way up. You just keep going, right? There's no gaps in between. Okay, this would be continuous. Okay, so it's not discrete, this is continuous. So when I'm doing continuous, I can't just easily count stuff. So another way to do it is with a graph. So if I were to go here to this graph and it says, probability that a student makes $17 or more. So let's do this again. X is squared equal to 17. Well, I would go to 17 on my little graph here, and I would say, all right, it's anywhere between 17 and 20. So anything in here is a possibility. Well, we need to go back to some old-time geometry here and figure out what this means. All right, well, what would be, notice this is from 10 to 20. If I'm talking about a normal curve, or if I'm talking, I'm not sure I should say that, a probability curve, remember, under the curve, the area is always 1. So if I was going from 10 to 20, how tall would this box have to be? So in other words, if I were talking about a rectangle here, and I said this is 10, and I know that the area is 1, what would the height have to be? It would have to be 1/10, right? Because 1/10 times 10 is 1. So this height right here would be 1/10. All right, well now this helps me figure out what this probability or this area is, because this is 17 to 18 is 1, 2, 3. So this would be 3 times the height, 1/10, which would be 0.30 or 3 over 10. Okay, so when you're dealing with a probability curve, it doesn't have to be a curve, it could be a rectangle, whatever. The area inside of it is always 1. And I know some of you are probably struggling with this, but this is from 10, because remember we said it could be anywhere between 10 and 20. So here's my 10 to my 20. That's 10. 10 to 20 is 10. So I need the height to be 1/10 to make the area equal 1. So if I'm asking what's the probability that the wages are 17 or above up to 20, that distance is 3 and the height is 10. Okay, so it's 0.30. That's a little, I know it's probably a little hard for some of you, but it's okay. We're going to go to the next part. Now, suppose the wages are assigned randomly from a normal distribution. So remember, this is our old normal curve, right? The mean is 15 and the standard deviation is 3. Now, it's been a while since we did the normal curve, so hopefully you can do this. But it says let Z be the daily wage. Now, is this discrete or not discrete? Well, remember in a normal curve, anything's possible under here. So any number is possible. So again, this would be no. There are infinite values with no gaps. So again, you could have $9.01, $9.12, $9.12.5, whatever. Any of those things are possible. But now, what's the probability that a student makes $17 an hour or more? So again, X is greater than or equal to 17. Well, now since I have a normal curve, I just go to where 17 is. So I don't know, maybe somewhere right here. And remember, it's greater than or more. So I'm going to shade to the right like that. Now, I don't know if you remember this or not, but we could find the z-score for this. Remember, the z-score is the observation minus the mean divided by the standard deviation. Right? So there's my observation. The mean is 15 right there. The standard deviation is 3. That means my z-score would be what do you know, 67. Okay? So now there's a couple ways of doing this. So if we take our calculators here, let's go to my calculator here. So we need to find the area on the normal curve. So remember, go to menu, we go to statistics, we go to distributions, and remember normal CDF right here, normal CDF. If I'm going too fast, hopefully he can rewind it a little bit for you, normal CDF. Okay, so lower bound, 17. Upper boundary, infinity. So I'm just going to put 99999. The mean is 15. The standard deviation is 3. Hit enter. And this would be my probability, 0.2524. 0.2524. You could round it up if you want, but that's fine. This would be my area right here. Okay? So the probability that a student makes $17 per hour on the normal curve is around 0.2524. Now, The reason why these are all different, of course, is because it depends on whether or not it's discrete or continuous. If it's discrete, remember, there's only so many values here we can choose from. There was only 25. That's the only number that's bigger than 17 because you can't do 18, 19, 20, or 21 because there's gaps there, right? Down here, this one was a little different because now we did a probability curve where the height and the width were specifically shown to us. But down here on the normal curve, well, now the normal curve, remember, there's infinite many values in here, okay? So it really does kind of matter if you know if you're talking about a discrete variable or a continuous variable. Discrete, you're going to be looking at something like this, where it's easy to see where they're at. Continuous, you're going to have to do some shading because there's so many different values in there, okay? So let's go to the back here. I don't know, we'll cut it maybe in half, I don't know. So the first thing that we're going to talk about are the random variables. Okay, so there's two that we're going to talk about. The first one is discrete, is what we talked about yesterday. And again, this is countable numbers. Oh, I should say countable number, of values with gaps. So the gap is like from 1 to 5. So there's a gap, right? There's no 1.1, there's no 1.3, there's none of that. It's just 1, and then the next number is 5. And then continuous. All right, so continuous, this one has an infinite, or should I say, has infinite values with no gaps. Okay, no gaps at all. So again, this is what you would use a normal curve on, okay? So infinite values with no gaps, 1.1, 1.11, 1.21, and so on, and so on, and so on. Okay, so those are those. So then we have to decide, well, what probability are we going to use? So we're going to talk about probabilities here. Okay, so if you can have a chart, of course, you just chart them like we did in the first part. But if it's continuous, well, we have to find the area under a curve. Find area under a curve. I'm having a hard time writing here. Find area under a curve. Now there's different types of curves. There's a uniform curve. That's the first one that we did. I know we haven't spent a lot of time on these, but this is basically a rectangle where the length is k, and so the height would be 1 over k. That's the easiest way to think about it. And then you're just trying to find some kind of shading in here and find the area, okay? The other one, of course, would be the normal curve. Normal curve. Remember the normal curve? We just do the old, mu and standard deviation there. And again, we just use our calculators and we find the area. This is the normal CDF, okay? So different ways to find the probabilities, but the hardest part, well, I don't know about the hardest part, but the most important part really is deciding, is it continuous or is it discrete? Because it changes the way that you find the probability. Discrete, you just simply count using the table that you're given, and it's easy, you just add up those probabilities for those values. If it's continuous though, then you gotta do some kind of curve, okay? So let's see if we can figure this out here on this check for understanding. So those who play Minecraft, the amount of time they spend playing per day is approximately normal. Now there's your key right there. That means I'm gonna need a normal curve, right? With a mean of 150 minutes, standard deviation is 42.7. Suppose we choose a random player, okay, to figure out the time that they're playing. Now, is it discrete or continuous? Well, as soon as we say normal curve, we have to say this is continuous. Okay? There are an infinite number of possible times for playing with no gaps. There are infinite number of possible times for playing with no gaps. You could play 150 minutes, you could play 150 minutes and 1 second, 150 minutes and 2 seconds, 150 minutes, and so on, so on, so on, so on. So it's continuous, okay? So now it says, find the probability that the average randomly selected Minecraft player plays less than 90 minutes. So remember, this is just a normal curve. So it says approximately normal. It tells me that the mean is 150. The standard deviation is 42.7. And so now, let's just put 150 in the middle here. Less than or equal to 90. So I'll give you a minute to catch up with me here. So now less than or equal to 90. So less than or equal to means to the left. So I just got to put 90 to the left here. And then I'm just going to figure out, okay, using my calculator, what's this probability? Now, we need to start getting into the habit of anytime that we do this to find the z-score. Now, the reason for that is because the AP exam. The AP exam, they always want you to write down the z-score, whether or not you use it in your calculator. So let's just do that. So z equals the observation, 90, minus the mean, 150, over the standard deviation, 42.7. So this z-score is actually negative 1.41. Now, a negative z-score means this is less than the mean. So we're expecting the probability, to be probably pretty small because it's less than the middle of the curve. But we can find it out now. So let's do our calculator here. So I'll pull out my handy dandy calculator. So again, menu, statistics, distributions, normal CDF. Now, I'm looking at a lower boundary of negative infinity because it's shaded to the left. So my upper boundary is going to be 90. My mean is 150. My standard deviation is 42.7. And that means at around, 0.0799. So I'm going to write it as 0.0799. Now, if I write it out and I interpret it, I would say there is a 0.0799 probability of choosing a Minecraft player who plays less than 90 minutes. Okay, so there's the probability. There's a 7.99% chance that if I pick a random player, they will have played less than 90 minutes. Okay? All right, now the second one says, find the probability of a randomly selected Minecraft player that plays between 90 and 120 minutes. Okay, so again, I'm just going to draw my normal curve here. You can be drawing a lot of normal curves in the second semester, so you might as well just get used to it now. Put 150 back in the middle. Okay, and now I need to shade between 90 and 120. So again, I just got, you don't have to be super accurate where you put 90 and 120. It just needs to make sense. Like you wouldn't want to put 120 over here. That doesn't make any sense. So now I'm trying to find this area in between, right? Trying to find this area in between. Okay, well now I have, I already found the z-score for 90, right? That's negative 1.41. So what I'm going to do, so I don't have to write it again, I'm going to do this, negative 1.41. But now I'm going to find the z-score for 120. So 120 minus 150 over 42.7. So z of 120 would be negative 0.70. Now, even though I'm not going to use that, I still need to write them both down so the AP readers know I know what I'm talking about. So now I'm going to go back to my calculator here. Okay, so here's my calculator. I'm going to go menu, get to my normal CDF. Now, I have a lower boundary now of 90, so I got to put 90 in there. Upper boundary is 120. Mean is 150. Standard deviation is 42.7. Okay, so now I have a lower and an upper boundary shaded. Okay, so then I put it in, and that gives me about 0.1612. If I round it, you can leave 0.1611, it doesn't matter. They're not going to care. That rounding doesn't matter. And so now I just got to interpret it. There is a 0.1612 probability of choosing a Minecraft player who plays between 90 and 120 minutes. And there it is. Okay, so again, when you're doing your homework, make sure first of all you understand, is it discrete or is it continuous? Because that changes how you have to do the problem. Discrete, again, you just look at the chart, you count, no big deal. Add the probabilities. Continuous, you're going to have to either draw a uniform curve, but most likely you're going to have to draw a normal curve. Once you draw the normal curve, you got to make sure you shade it. Once you shade it, find the probability. Find the z-score. It's just good practice for you. You're going to have to do it, so you might as well. So find the z-score and then use your calculator. All right? Okay. Good luck.